So now our concept is about Maxwell's bridge method. As I said, we are having resistor, inductor and capacitor. To find the value of inductance in the circuit, one of the way is the Maxwell's bridge method. So this is also a bridge method like Wheatstone bridge. So here we are going to create the same bridge like Wheatstone, like we are having a resistor and again a resistor, resistor and a resistor. Okay, so here we are going to give the supply to the circuit. So this is our regular Wheatstone bridge circuit. Same way we are going to have the circuit. But here the difference for the Maxwell's bridge method is, here we are going to have an inductor, because as I said, Maxwell is used to find the value of inductor in the circuit. So this is the little difference, that's it. Clear? So now this is R1, R2, R3, R4 and our inductances are L1 and L3. So that R1, L1, L3, R3, you can say they are in the same line. So that's why I name them as 1, 3. Okay, of course, anyhow we will have a deflection galvanometer like this. So that's it. Okay, so now according to Wheatstone bridge, a bridge method, if you are having a bridge circuit, such a bridge circuit in which L1 is the unknown resistance and L3 is a unknown inductance, and this is an variable inductance. Okay, so here we are going to keep a unknown resistance and unknown inductance, and then we will keep our known resistors with a variable inductance. That's it. So this is a detector. Now the L1 can be found out, so that the magnitude of L3 should be of the same order as that of this L1. Okay, so now we need to balance the bridge. That's what we are using, right? Bridge method means we need to balance. So to balance, we are considering one of the resistors R2 and R4. Okay, now we will adjust the inductor, means we are increasing. We are adjusting the value of the inductor in such a way that this bridge is balanced, right? So now simply just forget about everything. Just this is the circuit, and usually what we know is R1 by R2 is equals to R3 by R4. If we are having a bridge thing, 1 by 2 is equals to 3 by 4. That's what we know. So just blindly apply the same thing here. But here, instead of resistance, what is there? Resistance with a combination of inductance is there, right? So just to remember, if you are having a resistance in the circuit, we write it as R. If you are having an inductance in the circuit, we write it as J omega L. And if you are having a capacitance in the circuit, we are going to write it as 1 by J omega C. Or sometimes we can even write minus J by omega C. Anything is valid. Okay, just remember these 3 points for this unit. Okay, so by considering this, now what are we saying? The resistance is in series with inductor, means R1 plus R2. When two elements are in series, R1 plus R2 is the R equivalent, right? So here now what will be the R equivalent? R1 plus L1, but L1 should be written as J omega L1, right? So that's what I'm going to write. So I'm going to write it as R1 plus J omega L1. R2 means we have only R2, no worries. R3 means again we have combination with resistance and inductance, means R plus J omega L. But R means R3, L means L3. So divided by R4. So this is our equation. Clear? So from this equation, just say that you need to know the L1 value and R1 value, because these are the two unknown elements in this whole circuit. So our target is to find R1 and L1. So for that, what I am going to do? So the way I am going to do is just separate them. R1 by R2 plus j omega L1 by R2 is equals to R3 by R4 plus j omega L3 by R4. So now what I am going to make is, I am going to equate real part equate and imaginary part equate it. So if you equate the real part, here what is the real part? These two are the real parts because these are not having any j element, right? So we can say them as real part. So R1 by R2 is equals to R3 by R4. So our requirement is R1. Therefore I will say R1 is equals to R2 R3 by R4. Imaginary means j element, means omega, j omega. So I can write it as L1 by R2 is equals to L3 by R4. Therefore I can say L1 is equals to R2 by R4 L3. So finally our answer is R1 is equals to R2 R3 by R4, L1 is equals to R2 by R4 into L3. So what is Maxwell's bridge saying? This is also a bridge element, like bridge circuit, which is having 4 legs. So opposite legs are written like this: R1 by R2 is equals to R3 by R4, ratio of opposite legs. But R1 is with combination of inductor, R3 is also in combination of inductor. So that's the reason we got this equation. Now we are supposed to equate real part separately and imaginary part separately. When we equated real part, we got R1. When we equated imaginary part, we got inductor value. So finally we can say this is the unknown resistance value and the unknown inductance value when R2, R4 and L3 were given in the problems. This is how you can solve a problem for this Maxwell's bridge method. Are we clear? So regarding this, I am going to do one problem. So you can just check the problem as well. Clear?